Hi, everyone. Today we're going to be learning about our section 8.3, which focuses on rational exponents. Our learning objectives for today are simplifying expressions with the form of a to the 1 over n or with the form of a to the m over n, and then using our properties of exponents to simplify expressions with rational exponents. Okay, so let's get into it. Let's do some warm-up problems. We have two fractions being added to one another in this first example. What we have to keep in mind here is we need to make sure that our denominators are the same. So let's find an LCD between 15 and 12. We can do our handy dandy cake method off to the side over here. And we know straight off the bat that 3 goes into both of these numbers. 3 goes into 12 4 times, 15 5 times. And 4 and 5 are relatively prime, so we take the product of that little boot, 3 times 4 times 5, which gives us 12 times 5, which is simply 60, our LCD. Now what we want to do is we want to multiply these two fractions by our fancy forms of 1 to manipulate them into our equivalent fractions. So 4 times 15 gives us our 60, and 12 times 5 gives us our 60. So essentially, we're looking at 4 times 7, which is 28, 5 times 5 is 25, all over 60. Add the two numerators up, and you get 53, all over 60. And we're done. Part 2 has an A and a B. And so we're just reviewing our knowledge of our properties of exponents. We have 4x squared y to the 5th raised to the 3rd power. 4 to the 3rd is just 4 times 4 times 4, which gives us 16 times 4, which is 64. And then x squared raised to the 3rd, multiply the exponents, and we get x to the 6th. Y to the 5th raised to the 3rd, multiply the exponents, and we get y to the 15th. And we're done with that part A. Part B is just reviewing our understanding of negative exponents. Anytime there's a negative, that does not mean the number turns negative. In fact, it will never be negative. It just means we have a fraction. So it's 1 over the positive version of what we're talking about. And 5 to the 3rd is 125. So our final result is 1 over 125. Right? Not too bad. So let's zoom in on our first objective for today, which is simplifying expressions with a to the 1 over n. And so rational exponents are just another way of writing expressions with radicals. When we use rational exponents, we can apply the properties of exponents to simplify expressions. Rational exponents are just fractional exponents. When you think of rational numbers, think of fractions. Any form of number using the variables p over q, where both p and q are integers. And then we have our whole formal definition of a rational exponent down here. Again, really emphasizing the fraction 1 over n. And the denominator of that rational exponent is the index when we're converting it into our radical or our root form. So now let's practice our first example for today. We just want to convert this expression into a radical expression. So it's going from a rational exponent into a radical expression, aka root form. And x to the 1/2 is the same as just the square root of x. You could put that index 2 there, but you don't have to. Not with square root. And then we're done. What about part B, where we're looking at y to the 1/3? Well, again, that denominator is your index. So if our index is 3, we're looking at a cubic root. So we can write this as the cube root of y. And we're done. Let's look at example 2. Now we're doing the opposite. We are given that radical expression, aka our root form. And now we want to convert it to a rational exponent, aka that fractional exponent. So square roots, exponents are to the 1/2 power. So we have 5y raised to the 1/2, and we're done. And then in part B, we have 3 times that 4th root. So this is the same as 3 times 5z raised to the 1/4 power. And we're done. Okay. Let's do some more examples together. 25 to the 1/2. We're gonna simplify that in a moment. This is where really understanding these conversions will help come in handy, because 25 to the 1/2 is the same as the square root of 25, and we know that the square root of 25 is just 5. And then part B, we have 256 raised to the 1/4 power. Well, that's just the same as the 4th root of 256, which is just what times what times what times what gives us 256. And first we want to ask us, is it a whole number? Well, we know 2 to the 4th is 16, so it can't be 2. What about 3 to the 4th? Well, 3 to the 3rd is 27, 3 to the 4th is 81. That's still smaller than 256, so let's try 4. 4 times 4 gives us 16. And another 4 times 4 gives us 16. And would you look at that? 16 times 16 gives us the number we need, 256. So the 4th root of 256 is just 4. And we're done. I can maybe draw the arrow there so you know what we're solving for. All right, so we have a little note here. We just want to be very careful of the placement of the negative signs in the next example we're going to look at. And really keep in mind our properties of exponents dealing with negative exponents. A to the negative n is 1 over that positive version. So 1 over a to the positive n. Right, so now we have example 4. And we just want to simplify all of these examples. A, we have B, So, first example, negative 16 raised to the 1/4. That's the same as what is the fourth root of negative 16? And because it's an even index, this actually ends up putting us into the imaginary world. We can break this up into the fourth root of positive 16 and then the fourth root of negative 1. And we know 2 to the fourth is 16, so we have this guy over here is just 2. It's a different marker. But then the fourth root of negative 1, well, what times what times what times what gives you negative 1. If you know that I times I, that's our I squared, gives us negative 1, then we're looking at the square root of I, which is really just I to the 1/2 times I to the 1/2 times I to the 1/2 times I to the 1/2 is equal to 1. So the fourth root of negative 1 is the square root of I. You learn more about imaginary numbers in pre-calculus. In this course, you just need to know the basics. Definitely know that the square root of negative 1 is I. So the fourth root of negative 1 is the square root of I. Okay. Now let's look at part B. The negative is in the front. There are no parentheses. So we just want to look at the fourth root of positive 16. And then we stick that little negative in front. And that just gives us negative 2. And then finally, we have 16 raised to the negative 1/4. Well, this is the same as 1 over the positive version, so 1 over 16 raised to the positive 1/4, which is the same as 1 over the fourth root of 16, and this just gives us 1 over 2, otherwise known as 1/2. And we're done. Let's move on to our second objective for today. Okay, so we can look at a to the m over n in two different ways. So think about powers and properties of exponents once again. We can either look at it as just our good old a to the 1 over n raised to the m power, or we can switch these around, a to the m raised to the 1 over n. So if we were to convert this root form, aka this rational exponent form, into radical expression form, we would get the following. Our a to the 1 over n raised to the m is the same as the nth root of a raised to the m, or our a to the m raised to the 1 over n is the same as, once again, our nth root of a to the m, where our m is inside the root, not being raised by the entire root. Okay, and then this is just our formal definition of these different forms of our rational exponents dealing with our a to the m over n. So now let's look at some examples that really put this into action for us. So we have an A, we have a B, and we have a C. First one we're looking at is our square root of y to the third. Our second one is our cube root of 2x raised to the fourth. And then our last one, we have the square root of a fraction 3a over 4b raised to the third. Okay. So we want to write it with a rational exponent, aka fraction, as an exponent. Our index with part A is 2 because it's a square root. That goes into our denominator. So square root of y to the third is the same as y to the 3 over 2. And we're done. That second example, our index is 3, and then it's being raised to the fourth power. So once again, that index goes into our denominator. We're looking at 2x raised to the 4/3 power. And we're done. And then finally, that part C, let's zoom in on that. We are once again dealing with an index of 2. So once again, index 2. And we can rewrite this as 3a over 4b, all raised to the 3 over 2. And let's keep going. Example 6. Once again, we have a part A, a part B, and a part C. We are asked to simplify 125 to the 2/3 power, 16 to the negative 3 over 2 power, and 32 to the negative 2/5 power. So start with the first one. Let's first look at that denominator, aka our index. We're going to convert this to roots because it'll be easier. We know what the cube root of 125 is. That's just 5. And then 5 squared is 25. So that's our simplified result. In our second example, it's a negative exponent, so it's 1 over the positive version of this. And then our denominator in that fractional exponent is 2. So we can take the square root of 16 and then raise it to the third. Square root of 16 is just 4. And then 4 to the third power is the same as 4 times 4 is 16. And 16 times 4 is 1 over 64 for our final result. And then in part C, we have another negative exponent. So again, 1 over the positive version, 32 raised to the 2/5. What is the 5th root of 32? That's just 2. And then we raise that to the second power. So 5 to the second is 25. So our final result is 1 over 25. And there we have it. Let's look at some more examples. Just so you guys get into the comfortability of dealing with rational exponents and radical expressions, especially when we have negatives involved, whether they are in the coefficient or in the exponent. Right? So part A, that negative is in front and there are no parentheses. So we're just going to stick that negative there for the time being. Taking the square root of 25 and then we're cubing it. Square root of 25 is 5 and 5 cubed is 125. So our final result is negative 125. Second example, again, no parentheses, so that negative just chills in the front. And then we have a negative exponent, so we have 1 over 25 to the positive 3 over 2. And we just calculated 25 to the 3 over 2. That's just simply 125, so we can just rewrite this as negative 1 over 125. And then we're done. And then finally, part C, the negative is now inside the parentheses. So we're looking at the square root of negative 25 and cubed. And because the square root is an even index, we know straight off the bat there's no real solution here. We jump into that imaginary world, which we'll solve, but you just want to keep that in mind. It's not a real number anymore. We know the square root of 25 is 5, and then the square root of negative 1, so that's what square root of negative 25 can be broken up into, square root of 25 times the square root of negative 1. That's just I. And then we want to raise this to the third power. And so this is the same as 5 to the third times I to the third. 5 to the third is 125. I to the third is the same as I to the second times I. And we know that I to the second, put this off to the side, is just negative 1. So we have a negative 1 times I times 125. So this ends up becoming negative 125I. So, what did we cover throughout all of these past slides? We covered our review of product property, power property, product to a power, quotient property. We didn't really see our zero exponent definition, but we might see that soon. And then our quotient to a power property and negative exponent property. So this is just a summary of everything. If you don't have these notes printed out or on an electronic device, definitely write them into your notebooks. They will be very, very helpful. Okay, so let's do some more example problems together to really reinforce our knowledge of all of our properties. X to the 1/2 times x to the 5/6. When you multiply numbers that have the same base, you add the exponents. And when you're adding two fractions that have a different denominator, we want to make sure that we get the same denominator, so we must find an LCD. So what is the LCD between 1/2 and 5/6? Our LCD is just 6. Multiply that 1/2 by a fancy form of 1 to get that denominator to be 6. I'll zoom in so you can see it a little bit better. So now we're just looking at x to the 3 plus 5 all over 6, which is just x to the 8 over 6. And that's just reduced to x to the 4 over 3. Done. If you want to write it as a radical expression, you can also write it as the cube root of x raised to the fourth power. Either of these would suffice. Let's move on to part B. Part B, when we are raising a term to an exponent, we multiply the exponents. So we're looking at z to the 9 as a fraction is 9 over 1 times 2/3. Multiply straight across and we get 18 over 3. And 3 goes into 18 6 times. So our final result is just z to the 6th. And then when we're dividing terms that have the same base, we subtract the exponents. So we're looking at x to the 1/3 minus 5 over 3. Lucky for us, the denominators are already the same. 1 minus 5 is -4. So we get -4 over 3. That's a negative exponent. Let's turn it positive. So we get 1 over the positive version, x to the 4 over 3. And then if we wanted to put it into root form, 1 over the cube root of x raised to the fourth power. So either of these results are fine. If they specifically ask you to put it into rational exponent form, then you want to do that first one. If they ask you to put it into radical expression form, then we have that second one. Right? Let's do some more examples together. Really just trekking through it all. First one, we have 27u to the 1/2 raised to the 2/3. And then our second example, we have m to the 2/3 n to the 1 over 2 raised to the 3 over 2. So let's first take the cube root. And we can do this separately, the cube root of 27, and then we're squaring that. And then for u to the 1/2, what I want to do here is I want to first multiply that 1/2 by 2. And then we're going to take the cube root. So the cube root of 27 is 3, and then 3 squared gives us 9. U to the 1/2 times 2 is the same as just u to the 2 over 2, which is u. And then the cube root of that can't really be simplified more. So we can either keep our final result as 9 cube root of u, or if you want it into rational exponent form, 9u to the 1/3. And we're done. Part B, again, let's treat these separately. We have m to the 2 over 3 raised to the 3 over 2. That's a nice one. And then we have times n to the 1 over 2 raised to the 3 over 2. So that first one, multiply the exponents, and we end up with 6 over 6, which is just m to the 1, which is m. And then that second one, multiply the exponents, and we're left with n to the 3 over 4. So we can either keep it as a rational exponent form or radical expression, the fourth root of n to the 3rd. And there we have it. get a little bit more complex, dealing with a bunch of different variables now and fractions and some negative exponents as well. So we have everything is raised to the 1/2 power. Let's focus on the numerator separately from the denominator. And I'm going to bring in that 1/2 to each term. So 16 to the 1/2, x to the 4/3 times 1/2, then y to the negative 5/6 times 1/2, all over now the denominator, x to the 2/3 times 1/2, and then y to the 1/6 times 1/2. Let's simplify this a bit. 16 to the 1/2 is the same as the square root of 16, which is 4. And then 4/3 times 1/2, well, 2 goes into 4 twice, and 2 goes into 2 once. So we're just looking at x to the 2/3. And then y to the negative 5/6 times 1/2 is y to the negative 5/12. All over. 2 divided by 2 is 1, so we get x to the negative 1/3. And then we have a y to the 1/12. Once again, let's utilize some properties of exponents. When you divide numbers that have the same base, subtract the exponents. So what are we looking at here? We're looking at 4, and then x to the 2/3 minus a negative 1/3, and y to the negative 5/12 minus 1/12. So 2 negatives turn to a positive. 4x to the 3/3, y to the negative 6/12. This is simplified to 4x y to the negative 1/2. And if it's a negative, we can stick that into the denominator. So let me just shrink this a little bit so we have a little bit more space. So our final result, 4x in the numerator, all over y to the 1/2 in the denominator, or in radical expression form, 4x over square root of y. Now, if they asked you to rationalize the denominator, then you would have to multiply by square root of y over square root of y, and you would get 4x square root of y all over y to make sure there's no radical in the denominator. And maybe I'll write that as a little side note. Oh, there we have it. We're good to go. And that was our last example from this section. These are some just additional workbook exercise problems for you guys to check out on your own to really enforce your understanding of this material. But other than that, I hope that this was useful. Let me know if you have any questions, and I will see you guys next time. Take care.